Hi everyone, welcome back. Today we're going to talk about section 3.4, which is equivalent statements, which are an important concept when we study logic. We need to know whether the two statements mean the same thing or if they don't. Two statements are equivalent if both statements have exactly the same truth values in the answer columns when we construct the truth table. There's two ways to symbolize equivalent statements. You can use a kind of double looking arrow, or you can use, it's like an equal sign with an extra bar on top. The one that your textbook pretty much uses is the one that's the double arrow, but please don't confuse it with a biconditional. So remember we talked about in the last section biconditional statements, which are if and only ifs. So they're also double arrows, but they look slightly different. So that says P if and only if Q. If you look at this symbol, it represents logically equivalent statements. To determine if two statements are equivalent, we're going to construct truth tables, just like we did, and then we're just going to compare the answer columns. If the answer columns are identical, then the statements are equivalent. And if they're not identical, then the statements will not be equivalent. So in our first example, we're trying to determine if the first statement, which says P and Q or R, is equivalent to P and Q or P and R. So we're going to construct truth tables and compare the answer columns. So first let's take a look at the blue statement. So we have P, Q, and R, which means we need to have a column for each of those. I need to take my statement Q or R, and then I need to have a column for the answer, which is P and Q or R. Okay, so now I'm just going to determine whether it's true and false. So remember, for P, we're going to have true, 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 false, false, false. And Q is going to be true, false, true, false. And R is true, true, false, false. Now we have every combination of possibility for true or false for the statements P, Q, and R. Now I want to look at Q or R. So if you'll recall, an or statement is true as long as one of them are true. So if I look at column Q and R, I have true, true, so that's true. False, true, one of them's true, so the statement overall is true. True, false is true. False, false would be false because there's no trues there. And then it's true, 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 false. Now I'm going to look at P and Q or R. So I'm going to focus on the P column, and then I'm going to focus on the Q or R column. And it's an and. So remember, and means both have to be true for the statement to be true. So when I look, I have two trues there. And here I have two trues. And here I have two trues. And that's it. So they're the only places where I'm going to have true. The rest will all be false, because an and implies both have to occur. Now, that's my answer column. I'm going to compare that to the other statement. We already have P, Q, and R written out, so all I need to worry about here is P and Q, P and R, and then my final overall statement, my answer column, P and Q, or P and R. So now I'm looking at P and Q. Again, and both needs to be true. So if you look at column P and column Q, they're both true, so that's true. True, false is false. True and true is true. True and false is false. And then the rest are all false. Now if I compare P and R, I'm going to do the same thing. I'm looking at the P column and the R column. Both have to be true for the statement to be true overall. So P and R is true and true. That's true. True. False. False. And false for the rest. Now I'm going to take these two columns and it's an OR. So or, only one of them has to be true for the whole thing to be true. So that's true, true. I have a false and a false, which is false. And then the same thing for these. And now I'm going to compare each of the columns. So I'm going to compare this column here, my answer column here, to my answer column here. And as long as I have the same truth values, both of those statements are true. And if you compare, you've got true, true, false, 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 false in both. So therefore, both of those statements are true. So we can write something like this. So the three dots mean therefore. Therefore, P and Q or R is equivalent to, so double arrow with like the equal sign, P and Q or P and R. In the next example, we're going to compare if the statements are equivalent. So I'll give you a second to read letter B, and feel free to pause B and then unpause when you're ready to begin. B says, if you win your fantasy football league and you are here Friday, then we will celebrate. If you do not win your fantasy football league or you are not here Friday, then we will not celebrate. So here's statement number 1, and then here's statement number 2. And we're going to look to see whether they are equal. So the first thing I need to do is write out what P and Q are. So in each of the statements, it talks about winning fantasy football. So remember, P, Q, and R will be positive. So you're going to put, for P, you win fantasy football. Q would be the second part of the statement. You are here Friday. And R is the third part of the statement, which is we will celebrate. So if I want to convert number 1 to a statement, it says if you win fantasy football, so that's P, and you are here Friday, that would be Q, then we will celebrate. So this is an if-then. So I need to put my arrow to the right, and we will celebrate as R. I also have two connectors here. So I'm going to put P and Q in parentheses, as we discussed in 3.2. And for my second statement, I'm going to do the same thing, except now it says, if you do not win fantasy football, or you are not here Friday, then we will not celebrate. Again, it's an if-then. And we've got two connectors, so we need to put parentheses around the first part. You do not win fantasy football, or you are not here Friday, then we will not celebrate. So we're looking to see if both of these statements are equivalent. You can pause the video and try making a truth table and then unpause, and you can check your work with what I have. So we've got P, Q, and R again. And now I need P and Q. So ands are true and both are true. So look at the P column and the Q column. I'm only going to put a true when I see both are true. And now I need the last column, and it's an if and only, it's an if then. So if P and Q, then R. So remember, for if thens we discussed in 3.3, you want to think of this as, did you keep up with your end of the bargain? So if it's true, the bargain part, which would be the last part here, if that's true, regardless of whether this is false, the whole statement's true because you kept up with your end of the bargain. So now the tricky thing is P and Q comes first. So we're going to look at this column first and then compare it to R. So as long as R is true, the whole statement's true because you kept up your end of the bargain. So if you remember the example we did in 3.3, it was something like, if you get an A, then I'll buy you a car. So as long as I buy you the car because you got an A, it's true. So anywhere R is true, we're going to put a T. Here, it's true, false. So that's false. I didn't keep up with my end of the bargain. Here, even though it's false, false, that's true because it's the equivalent to, if you didn't get an A, then I'm not buying you a car. Well, that's true because I'm only buying you a car if you get an A. False, true is true. False, true is true. False, false is true. And false, false is true again. So the only place I have a false is in that third line there. Now I'm going to compare it to the other statement. So in the other statement, I have not P, not Q, and not R. So not just means make it opposite. So I'm going to look at the P column, and I'm just going to make everything opposite of what I have. Same thing with Q, and same thing with R. Now I need not P or not Q. So or, remember, only one of them has to be true. Now I have everything I need for my last column. And remember, if thens, you need to put a true as long as you kept up your end of the deal. So this part comes first, this part comes second. So I'm going to look at the not P or not Q and then compare it to not R. As long as not R is true, it's going to be true. So this is false, false, which is true because I kept up my end of the deal. Remember, you didn't get an A, so you didn't get a car. That's true. Here it's true, false. So that's like saying, okay, you got an A, but I didn't get you a car. Well, I didn't keep up my end of the deal. That's false. And then I've got false, true. So that's true, 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 false, true, false, true, 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 true. Now let's compare our answer columns. So I'm going to compare this column to this column. Are they identical? As you can see, they're not. So therefore, these are not equivalent statements. Remember in chapter 2, we looked at De Morgan's laws for logic. Here they are again. So law number 1 says it is false that P and Q, and then is equivalent to not P or not Q. And law number 2 says it is false that P or Q, and then you have is equivalent to not P and not Q. So if you'll remember in chapter 2, we didn't use quite those symbols. We had something like this. A or B, the complement of A or B, we said was equal to not A or not B. That was law number 1 or number 2. I don't remember which one. And then the other law was not A or B was the same thing as saying not A and not B. Now we're just changing the symbols, but the meaning is still the same. So we're going to use De Morgan's laws to select a statement that's logically equivalent to I do not have instruments, but I do not have investments, but I do not have debts. So what we want to do to determine which are equivalent is first change that statement here. So I do not have investments, but I do not have debts. Change that to P and Q. So remember, P and Q will always be positive. So for P, I'm going to say I have investments. And for Q, I'm going to say I have debts. Now, if I rewrite that statement using symbols, it says I do not have investments. So that would be not P. And then but we treat just like an and. And I do not have debts. So this is not P and not Q. We need to determine which of the following A, B, C, or D is equivalent to that. So all we're going to do now is convert each of these statements to symbols. So in letter A, it says, I do not have investments. Okay, so that would be not P. And then it's or, so upside down, or it would be a V rather. And then I do not have debts. Letter B, it is false that. Anytime you see it is false that, you need to put a tilde and then parentheses. So I'm going to have tilde, I have investments, so that's P, and is an upside down V, I have debts. It is false that I have investments or I have debts. And letter D is I have investments or I have debts. Looking at each of these choices, A, B, C, and D, which one is equivalent to not P and not Q? So using De Morgan's law, we find that C is the one that is equivalent. If you look at De Morgan's law, it says not P or Q is equivalent to not P and not Q. And that's what we have there. So C is the answer. Next, we're going to talk about conditional statements as disjunctions. Statements containing connectives such as and or may have equivalent statements. So here's an example. This says if P then Q is equivalent to not P or Q. This allows us to write a conditional statement as a disjunction or a disjunction as a conditional statement. So for example, instead of saying, if the game is baseball, then you use a bat, you can say, the game is not baseball, or you use a bat. Remember, or, one of them has to be true for both of them to be true. Well, if the game is not baseball, then you're not using a bat. If you use a bat, then the game is baseball. These are equivalent statements. So to change a conditional statement to a disjunction, you're going to negate the antecedent, which is the part that comes before the word if, or after the word if. So it'll say if something, this right here is the antecedent. And then we have changed the conditional symbol to a disjunction symbol. So you're going to change the arrow to a disjunction, which is an or. And then you're going to keep the consequent the same. So recall that the consequent is the part that follows the word then. So it'll say then whatever. That's the consequent. And then the next part is basically the same, except we are going from a disjunction, so an or, to an if-then statement, to a conditional. So let's look at an example. Write a conditional statement that's logically equivalent to the cows are in the pasture or the horses are not in the barn. Okay, so we have or, which symbolizes a disjunction. And we want to convert that then to a conditional, which is just an if-then. So therefore, what I'm going to do first is I'm going to negate the first statement. So my first statement is the cows are in the pasture. To negate that, I would say the cows are not in the pasture. Then it says change the disjunction symbol to a conditional symbol. So a conditional means if then. So I left some space after therefore because you need an if, then. And now it says keep the second statement the same. So the second statement is the horses are not in the barn. Both of these statements are logically equivalent because the cows are in the pasture or the horses are not in the barn. One of those has to be true for both the entire statement to be true. Saying that is equivalent to if the cows are not in the pasture, then the horses are not in the barn. So this is basically saying P or not Q is equivalent to not P, if not P, then not Q. We will use the fact that if P then Q is equivalent to not P or Q and De Morgan's laws to prove the following. So we want to determine a statement equivalent to it is false that if P then Q. So we want to use this if P then Q is equivalent to not P or Q. So I want to take this now and this and compare them. Okay, the only thing missing there is the tilde. So if I add the tilde to one side, it's an equation, right? It's equivalent. I have to add it to the other. So I'm going to put a tilde on the outside of my original statement. So I'm basically negating both sides. Now I don't have to do anything to the left side. To the right side, think of this as distributing a negative. So a tilde times a tilde, a negative times a negative, is a positive. And then a tilde times Q would be tilde Q. And remember, when you negate an or, it becomes an and. So therefore, what we just proved was that the statement, it is false that if P then Q is equivalent to P and not Q. You can pause the video and try proving the following. So using the fact that what we just proved, it is false that if P then Q is equivalent to P and not Q, what is it is false that if P then not Q equivalent to as a conjunction? So see if you can try that on your own. I'm going to solve this the same way that I solved the one right above. So I'm going to take my statement, which is it is false that if P then Q is equivalent to P and not Q. And what I'm going to do is try to prove this. So I'm going to compare that to this statement, and what's missing is the tilde next to the Q. So I'm going to add it into my equation. But if I do that, remember, whatever you do to one side, you have to do to the other. So since I negated q on the left, I've got to negate the q on the right, and it already has a negation symbol. What happens when you have two negatives together? They turn positive. So this side here just turns into p and q. So therefore, what did I just prove? I proved that it is false that if p then not q is equivalent to saying p and q. So there's different variations of conditional statements. What we looked at here were negations, but you also have three other variations, which are called the converse, inverse, and contrapositive. So remember that a conditional statement is if P, then Q. We're going to take if P, then Q, and we're going to move the letters around into other statements. So when you're dealing with the converse says just take the Q and the P and switch them. So the converse will say if Q, then P. For the inverse, you're going to go back to your original statement, if P, then Q, and all you're going to do is negate the antecedent and the consequent. So it'll be if not P, then not Q. And my contrapositive is go back to the conditional statement and you do two things with the contrapositive. So you're going to switch it around just like the converse, but you're also going to negate it. So the word contrapositive, contra means against, like to contradict someone. So you're against being positive, that means you're negative. So you switch them around and you negate them. What's interesting is the conditional statement and the contrapositive are actually equivalent statements. And the converse and the inverse are equivalent statements. Okay, let's practice using them. So P in this problem is the number is divisible by 10, and Q is the number is divisible by 5. We're going to write the following conditional statements and determine which are true. So remember, when we say divisible, we mean can these numbers divide into a number? So for example, 20 is divisible by 10 because 20 divided by 10 is 2. But 25 is not divisible by 10 because you can't divide 25 by 10 evenly. Okay, so let's remember that. So my conditional statement, if P then Q, is just going to say if the number is divisible by 10, then the number is divisible by 5. We'll come back and determine whether that's true or false after we finish. Now we want to write the converse. So the converse, remember, is when you take P and Q and switch them. So the converse is just going to be if Q, then P. So I'm going to take my sentence now and just reverse it and say, if the number is divisible by 5, then the number is divisible by 10. The inverse is to just take P and Q and negate them. So the inverse is going to be if not P, then not Q. So I'm going to go back to P and Q, and I'm just going to say if the number is not divisible by 10, then the number is not divisible by 5. And the contrapositive says basically take the inverse now and just find the converse of it. So you're just going to take that statement and switch it around and just say, if not Q, then not P. So if the number is not divisible by 5, then the number is not divisible by 10. Let's figure out whether these are true or false statements. So if I go to A, if a number is divisible by 10, then it's also divisible by 5. So think of numbers 10 can go into. Will 5 always go into that? That's true. Think of the number 20. 20 is divisible by 10. 20 divided by 10 is 2. And you can also divide 5 into 20. It works for every number that 10 goes into. But now how about the converse? If the number is divisible by 5, then the number is divisible by 10. This is going to be false. 25 is divisible by 5. 25 divided by 5 is 5. But you can't do 25 divided by 10. So just because the number is divisible by 5 does not mean it's divisible by 10. For the inverse, if the number is not divisible by 10, then the number is not divisible by 5. That is also false. If we take our last example, 25 is not divisible by 10, but 5 is divisible. 25 is divisible by 5 because 5 can go into it. So that's also false, which we would expect because remember, B and C are equivalent. The converse and inverse will be equal to each other. And then likewise, the conditional and the contrapositive will be equal. So we should end up with true for the contrapositive, but let's look at it. If the number is not divisible by 5, then the number is not divisible by 10. Well, that's true. Think about the number 8. 8 is not divisible by 5. You can't divide 5 into 8 evenly. Well, the same goes for 10. 10 cannot go into 8. So that's a true statement. The last thing we're going to do here in this example is use the contrapositive to write a statement logically equivalent to, if you don't eat your meat, then you can't have any pudding. So here we're going to let P be, you do eat your meat. And Q is going to be the second part of the statement, you can have pudding. So the first thing we're going to do is write our conditional. So it says if you don't eat your meat. P is you do eat your meat. So if you don't, it would be the not P. Then you can't have any pudding. So Q is you can have pudding. So you can't would be not Q. So that's my conditional. Remember, to get a contrapositive, what you do is you switch Q and P and you negate it. So if I switch them, it's like this. And then when I negate them, if I negate something negative, it turns positive. Same thing with P. It's already negative. When I negate it, it turns positive. So what I need to have now is just if Q, then P. So what's Q? You can have pudding. So I would say if you can have pudding, then you can eat your meat. That's the end of section 3.4. If you have any questions, please let me know. But once you are finished notes and you have listened to the video as much as you need to, feel free to start on the assignment. Okay, hope you all have a great rest of your day.